All right, now we're in Taylor County, and we are right in the middle of the fall line or the sand ridge. So I don't care where you are in Taylor County. I don't care what color your dirt is. I don't care if you've got pebbles like this pebbly soil in it. I don't. You know, most likely if you're in Taylor County in this middle Georgia area, you have a sandy soil. You might have a sandy loam. You might have a little bit of clay, but you have a sandy soil. I mean, these soils right here, very coarse sand. And we're going to talk a little bit about the properties of these kind of sands. These pebbles, a lot of folks call this a good cotton soil. As you can see, it grows a pretty good sunflower too. But we're going to talk a little bit about the basics of our soils. Soils are classified based on their texture. You know, a sand is a clay, or a loam. Those are all textures. And you got to think about it in this way. Sands are the largest particles we have. Sandy soils have the largest particles. They're really large. As you move down to a loam, you got a little smaller particle size, and then when you move to a clay, you have a very, very small particle size. This is very important for a few things. The smaller the particle size, the more actual surface area you have on that soil. So the more area on that soil, you can hold things like you can hold water, moisture, and also you can hold nutrients. As you move to your larger soil sizes, which are sands, you have less surface area in a given area of soil, so you have less areas on that soil where you can hold nutrients and where you can hold water. Another thing to think about is when you have the smaller particle sizes, that soil can pack together a lot tighter. You can get a lot more closer to packed soil, so you have a lot less airspace in there, a lot less places for things to move through. So a lot of times in those smaller particle size soils, the water moves through it a lot slower. But there again, in your larger soil sizes, like your sands, you have big pore space, big airspace, where water and things can move through that soil very rapidly. One thing I failed to mention earlier is all of our soils are comprised of 4 things. They're comprised of mineral content, organic content, water, and air. And the only thing that really changes in a soil in a given area is the water and air percentage, which is usually about 25% each. And it just basically changes as you get more rain, you got less airspace. As you have less rain, like we've had recently, you have more airspace. So that's what the soils are made up of. And all of our soils have horizons. The upper soil horizon is our topsoil, which is usually that's the tillable soil, the soil that you can change, you can actually plow and till. Then you have your subsoil, which is where that topsoil came from, and that's usually where all your stuff that you put out, all your fertilizers and things accumulate. And then you got your parent material underneath that we never really get to. So that's your basic overview of the soils. We're gonna move over to my tailgate, and I'm gonna kind of show you, I'm gonna try and do a demonstration that will maybe help you understand better some properties of our soils and some reasons we need to look at our soils here a little differently than other places. All right, this is a little demonstration I've used for some Master Gardener courses, just to kind of illustrate the properties of these different soils. What I've got here is your good old Taylor County sand, and this right here is some good old Barnesville, South Lamar County red dirt. And what I'm gonna do is I'm just gonna pour some water in out of my baby jars, hope this works, just to demonstrate one pore size. Sandier soils have larger particles. Okay, on the right we've got a sandy soil. This is from Taylor County, taken back to my house from my daughter's sandbox. Makes a good sandbox. If you can look at that, you can see the particle sizes, large particle sizes. On the left-hand side is a clay from southern Lamar County. You have some chunks in there, that's just clumps of this red clay, but hopefully you can tell that this clay is a real fine, powdery, real dusty, small particle sized dirt. So what I'm gonna do now is I'm gonna pour some water in it. Hopefully it'll show you that these smaller particle soils will hold water more. The water will move through it slower, and this larger, sandier soil, the water should move through it a lot faster, and it'll show you the lack of water holding capacity of our soils over here in Taylor County. So I'm gonna pour it in there, and then we'll kind of pan back and take a look and see. Hopefully the cup paper towel water experiment works like it's supposed to. And as you can see, that big old bunch of water is already seeping out of our sandy soil. It's already running out down the tailgate of my truck. And in the clay soil, it's still sitting there. It's making its way through, but it's slower, a lot slower coming through. Hopefully that's kind of giving you, it's kind of showing you, the different particle sizes Water is going to move through our sands a lot quicker. There's a lot less water holding capacity. And as we'll talk about a little farther down in the show, a little later in the show, there's a lot less nutrient capacity. If you look at, we have some weather stations. We have one weather station in Byron, Georgia. We have a weather station over here west of Butler. And you can see it's just now finally seeping out of this clay. If you look after, say, an inch rain at the soil moisture the next day, the soil moisture on those weather stations, Taylor County sandy soils, we might be at 12% moisture, whereas at our Byron soil, that Byron and more clay soil, you could be up 30–40% moisture that next day. So the moisture holding capacity of a soil, very important. And it's in these different soils, they hold moisture different. So growing conditions are going to be a lot different, and it's going to change a lot more rapidly in our sandier soils. All right, so hopefully my little experiment with the water and the sand and the clay showed you kind of that, soil particle size is going to have an effect on the amount of water a soil can hold. So over here, you can go ahead and count on our soils holding less water than a more clay soil, and for that matter, a soil with more organic matter. That's one of the reasons, one of the reasons that the Midwestern soils, which have high organic matter, which is small particle sizes, why they have so much better growing conditions and growing soils than we do here. We have a more mineral soil, they have a more organic soil. Smaller particle sizes hold more water. Smaller particle sizes also holds more nutrients. Most of the nutrients that we put out for crops to grow have a positive charge. I know all y'all, if you don't remember chemistry or anything from high school or whenever, I know you know that magnets have a plus and a minus, and the plus and the plus don't attract, they repel. The plus and the minus attract. So these small particle sizes, they all have negative charges. Every spot on that small particle size has a negative charge. A lot of these things we put out for fertilizers have positive charges. So the more negative charges you have in the soil, the more positive things you can hold. So the more nutrients that soil can hold, that will actually then be available for a plant to take up. So real basic soil, basic soil chemistry lesson for you there. Smaller particle size, more negative, can hold more positive for the plants to take up. So once again, our sandy soils have fewer negative sites for our positive fertilizers we put out. So putting a big chunk of fertilizer at one time is not always a good idea here. For one reason, heavy rain, like we saw, will go through a sandy soil very quickly. So that heavy rain, will, for one thing, can just carry nutrients just straight through a soil, so it doesn't have a chance to bind that soil particle. Another reason is, if it does dissolve in the soil because we have adequate moisture, a lot of those nutrients can't attach anywhere because there's not enough places on that soil for it to attach. So that's why in sandy soils like we have here, we often tell farmers and gardeners and homeowners, you really need to kind of spoon feed a crop. You really need to put a little bit of fertilizer out at a time to kind of give it what it needs overall, but you need to give it to it in small little bits throughout the growing season. All right, like I said, it's December, and we're talking about soils. And one reason I wanted to talk about soils in December, which a lot of people don't think about their garden or their yard in December, is that this is the time of year, this is when we really need to be thinking about our soils. This is the perfect time of year to take a soil sample from your garden, from your lawn, bring it to our office, take it to the Peach County office, Crawford County, wherever you live, take it to a county extension office, have it sent off so that you know what's in your soil and so you know what your soil pH is. pH, for lack of just getting really technical, is the hydrogen ion activity in a soil, which is also the acidity or basicity. The higher the number, up to 14, is the more basic. The lower the number, the more acidic. Our soils here in Georgia are naturally acidic, in the range of 5 or so. Going from, and being 7 being a neutral number. And a lot of people don't think, from 5 to 6 to 7 is a big difference, but if you think about this, the scale, the pH scale, it's logarithmic, which I'm not getting into all that because I don't think I even paid attention and know what logarithms really were, but it's basically from 7 to 6 is a 10-fold difference, so from 7 to 5 is a 100-fold difference, if that makes sense. So 7 to 6 is not just 1 point. So when you look at your pH and it's a 5.5 and you're thinking, oh, it only needs to be 6, it's not that it's just 0.5, it's a 5-fold difference. So we really need to think about that, and this is the perfect time to think about it because you can get a soil sample, and if your pH is low, you can actually do something about it now, or even in January, and be ready for your spring crops that you're going to plant, your summer crops, and have time for to bring your pH up. And when I say have time to bring your pH up, what we use to bring your pH up, which most of you probably know, is we use lime. Lime reacts with the soil to raise pH by getting rid of some hydrogen ions. So it's a reaction. Now all y'all know, reactions don't just happen, most of the time don't happen just like this. It takes time. So the best thing to do, get your soil sample, realize your pH is low, put out the recommended amount of lime, incorporate that lime so it's spread throughout the soil profile and it can react with more soil. If it can react with more soil, then your pH should raise up sooner and you'll be more ready for the following year. Most of our crops, most of our vegetable crops require a pH of around 6 to 6.5. But as you can see from this chart, there is a range of pHs. When you talk about blueberries and things like that, they like a real low pH. Some of our other crops like a higher pH. But most of them, if you just want to say general recommendation, will be 6 to 6.5. Putting out lime at this time of year will get you ready for next year and bring that pH up. People ask about pH and why it's so important, and we've got a chart that I show all the time, and it shows the availability of crops based on pH. And if you look at the chart, in the middle part of the chart is a neutral or a pH of 7, neutral pH. And you can see that a lot of the nutrients that our plants need are actually more available, have a fatter line at this neutral pH. As you move towards a more acidic number, which is the lower numbers, a lot of these nutrients that can actually be toxic, like aluminum, zinc, things like that, actually the availability of them increases. We have a lot of aluminum in our soils in Georgia. They're not toxic to plants like these sunflowers because we have the pH at a high enough number that it's not even available to these sunflowers. If the pH out here was 4, these sunflowers may never grow because of the amount of aluminum they take up. And what happens when you get into pH, low pHs in a garden, and you have trouble, you have stunted plants, things not growing. What it is the plants are actually not available to take up crops. And I have another chart that I love to show people because it hits home when you look at dollar values and percentages, but a chart that shows you the amount or the percentage of a fertilizer that you waste when you go from different pHs. If you look at a 7 pH being, you get 100% availability of your N, P, and K, and then you go down to a 5, the percentage of N, P, nitrogen, phosphorus, and potassium that you lose because of that pH is pretty astounding. And if you look at the price of fertilizer these days, it isn't cheap. So if you're losing 50 to 70% of your fertilizer, you're really throwing a lot of money away because you didn't take a soil sample this time of year, come out in line, raise your pH up, and be ready for the spring. All right, so we talked about soils and things like that, and fertilizer and pH. One thing I didn't talk about was, when you are fertilizing, the basics of fertilizing and fertilizers. When you buy a bag of fertilizer, say 10, 10, 10, you're buying a product that has 10% nitrogen, 10% phosphorus, and 10% potassium in that bag. So a 50-pound bag of 10, 10, 10 has 5 pounds of N, 5 pounds of P, 5 pounds of K. So it's very important to know that when you get a recommendation. And we're just going to do a recommendation based on, say, an acre. Like I said, I've said before, and I tell people all the time, most of the time in a garden, I recommend a 300 to 500 pound rate per acre of, say, a triple 10. So 300 pounds of triple 10 will give you 30 pounds of each because it's 300 times 0.1, which is 10%. 500 pounds will give you 50 pounds. 500 times 0.1, 50 pounds per acre. If you need to break that down, if I give you a per acre rate recommendation, if you need to break that down on 1,000 square feet, say if your garden's 1,000 square feet, you want to know how much to put out there. An acre is 43,560 square feet. So if you divide that by 1,000, it's 43.56. So you would take that recommended rate, 300, and divide it by 43.56, and that'll give you the amount to put out per 1,000 square feet. If you need to change it down to 100 square feet, you divide it by 435.6. So that's just an easy way. I mean, that's just a basic, simple, real quick. How to change a per acre rate basis down to a 100,000 square foot rate basis, and the basics about what those numbers on a fertilizer bag mean, and as a percentage, and just help you out that way. You know, a lot of people, they see 10, 10, 10. I don't think they really know what they're putting out. You know, I say I just put a bag out per acre. So it, you know, the higher the numbers, the higher percentage, the more you're putting out, you know, per pound. So the higher the numbers, the less you'd actually have to put out on a small acreage. So, excuse me. Hopefully this will help you out. And if you have more questions about this, like I said, always call 862-5496, that's our office, or you email your questions to backyard@uga.edu. All right, the last thing I'm gonna touch on before we wrap this thing up and wrap up 2013 is organic matter. You know, you hear a lot of talk about organic matter from gardeners and organic farmers and things. And in Georgia, in the Southeast, in our humid, rainy, warm atmosphere or climate, it is very hard for us to build up organic matter in a traditional row crop type setting or in a garden type setting where we are continuously using tillage to break up the soil, to incorporate lime, to put fertilizer in the ground. It's hard to build up organic matter. The reason is the more you break up, say if you just came in here and mowed all this down, you'd have a lot of biomass, a lot of organic matter on top of the soil. If you grew rye cover crop that got 6 feet tall, you would have a lot of organic matter out here. And if you just rolled it down, press it down flat, it would stay here for a few years. But the first time you come in and till it up, break it up, chomp it up, you open that dead plant material up to the bacteria, the fungi, the bugs, you know, all the little microbes in our soil that will feed on that kind of stuff. So every time you do any kind of tillage, you decrease the amount of organic matter in our soils. The only way to really, like I said, the only way to really increase the organic matter is either by yearly applications of organic matter, composted, you know, chicken litter, putting out straw mulch, things like that, that will increase your organic matter, or reducing the amount of tillage you use. Very tough to do in a garden situation because we don't have implements and things to alleviate, you know, compaction under the soil while leaving the soil, you know, intact and the organic matter intact in between our rows. So it's really hard to do in a garden unless you do a lot of shoveling, a lot of hoeing, and a lot of backbreaking stuff. But organic matter is a tough thing to really, you know, accomplish other than just putting more organic matter out. I personally, in my garden, I use a lot of straw mulch. I mulch in between all my summer crops, and then I come back and mulch in between all my winter crops. So there's a lot of organic matter there, but it still gets turned under, and it, you know, after a year or two, you know, what I put out this winter, you know, next spring, you won't ever see it once it gets tilled under, watered a little bit, and those microbes start feeding on it. Another thing to think about with organic matter is as that organic matter breaks down, it takes those microbes, they use nitrogen to actually break it down. So you may actually have to, as it's breaking down early on, have to add a little extra nitrogen to fertilize your crops because those microbes are feeding on it as well as it trying to feed your crops. So that's just, you know, a little touch on some organic matter. It's a good thing to have in your garden. It's just hard in Georgia for Georgia gardeners to kind of keep it in place and even to raise the percentage of organic matter in our soils. It's a tough thing. Some people have been very successful at it, but it's something you got to kind of work at every year, and it can, you know, tillage can get rid of it really quick. Hopefully, like I said, there's a lot of information and there's a lot more. I mean, I was telling Jacob, I talked 2 hours about soils in a Master Gardener's course, so I could talk for a long time on soils, but I try to cram the basics and the meat of the biggest, most important part in this show to kind of give you a basic idea. Hopefully encourage you to go out and get your soil sample, bring it to our office, we'll send it off, analyze it. Once you get it back, you can give me a call and we can talk about the recommendations and, you know, ins and outs and how to fertilize, and hopefully start you off on the right foot for your spring garden and your summer crops, and maybe give you a more productive garden in your yard or lawn or even fruit trees and things like that. So, like I said in the start, this is the soil is the building blocks of what we need to really have a good, healthy crop, whatever crop we're growing, and hopefully this episode has helped you out. We'll see you in January of 2014. This is Backyard Basics. I'm Jeff Cook, where we're filmed here in your backyard or your sunflower field.